Hello class, today we're going to be combining two lessons, 8-2 and 8-3. They're both about parallelograms, and I think that it would be good to see all of this information together. So what I have drawn for you is a parallelogram. And so if we remember the definition of a parallelogram, it's a quadrilateral, meaning that it has four sides, with both pairs of opposite sides parallel. Okay? So in this case, PQ is parallel to RS, and also QR is parallel to PS. And that's just the simple definition of a parallelogram. So I have several theorems that we're combining from both of the lessons, 8-2 and 8-3, and you'll find that they're very similar to one another. So the first theorem that we're going to talk about is Theorem 8.3. And what it says is, if a quadrilateral is a parallelogram, then its opposite sides are congruent. So something that I could write down, in this case, I have quadrilateral ABCD. So if ABCD is a parallelogram, then by this theorem, I'm told that AB and CD are congruent. And also, BC and AD are also congruent. BC is congruent to AD. Okay, so that's what this first theorem is talking about. As if you're starting with a parallelogram, you automatically know this information. Well, you can also say the opposite, which is what Theorem 8.7 says. It says that if both pairs of opposite sides of a quadrilateral are congruent, then it is a parallelogram. I'm getting tongue twisted. So this time we're stating, if I know at the very beginning that, let's say, AB is congruent to CD, and also if BC is congruent to AD, then that's enough information to say that it is a parallelogram. Alright, so pretty self-explanatory. So let's move on to our next part. Next we have Theorem 8.4. And this one says, if a quadrilateral is a parallelogram, so again, we're just assuming that it's a parallelogram, then its opposite angles are congruent. So opposite angles would be like angle P and angle R. Okay, so that's what I'm going to write down. If PQRS is a parallelogram, then I can assume that angle P is congruent to angle R, and also the other opposite angles, Q and S, are also congruent. Angle Q is congruent to angle S. And you kind of guessed it, there's also a corresponding theorem that kind of says the opposite, that if you start with both pairs of opposite angles being congruent, then that's enough information to conclude that the shape itself is a parallelogram. Okay, so let's write that down. If angle P is congruent to angle R, and angle Q is congruent to angle S, then the quadrilateral PQRS is a parallelogram. Awesome. So I have a short example for us right here. We're given a quadrilateral, and we're also shown that JK is parallel to LM, but also the top segments, KL and JM, are also parallel. So So I'm kind of already told that it is a parallelogram because the opposite sides are parallel. And so we've learned some information already that by theorem 8.3, JK is going to be equal to ML. So I'm going to say that they're congruent right now, those two segments. So that means that JK 18 is going to be equal to ML, which is y plus 3. And I can solve for y. So in this case, y is going to be 15. Also, by another theorem, theorem 8.4, I was told that angle J should be congruent to angle L because they're opposite angles. And I'm already told that it's a parallelogram. So J is 2x, L is 50 degrees. So if I divide by 2, then I find that x equals 25 degrees. So this is just putting some of those theorems into practice. Okay. So let's go ahead and move on. I have lots of theorems for us today. The next one is theorem 8.5, and it says if a quadrilateral is a parallelogram, so again we're just starting with the assumption it's a parallelogram, then its consecutive angles are supplementary. So consecutive angles, remember we talked about consecutive interior angles or consecutive exterior angles, so that means that they're like on the same side. So looking here in this case, x and y would be considered consecutive angles because they're on the same side of, if this line FE continued to go, it would be a transversal. So I'm told from this theorem that x plus y are supplementary, which means that they add up to 180 degrees. Also, if you're turning and you're looking at it this way, these ones both lie on the same transversal, x and y on FG. So those would also add up to 180 degrees. So this is a pretty self-explanatory theorem, but we can only assume that if we're given at the very beginning that it is a parallelogram. So theorem 8.9 says this: if one pair of opposite sides of a quadrilateral are congruent and parallel, so we have to assume in the very beginning that FG and EH are not only parallel, but they're also congruent, then the entire shape is a parallelogram. So in this case, if FG is parallel to EH, and if FG is congruent to EH, then the whole shape EFGH is a parallelogram. So that's kind of cool. You only need to know two sides, and you can conclude that it's a parallelogram if this information is correct. All right, we're almost done. I have two more theorems for us. This next theorem is theorem 8.6, and it says if a quadrilateral is a parallelogram, so again, we're assuming in the beginning it's a parallelogram, then its diagonals bisect each other. Okay, so if we're told in the beginning that it's a parallelogram, it may not always have these little arrows to tell us, oh, those different sides are parallel to one another. So that might be something we have to put in ourselves if we're given that it's a parallelogram. But we're also told that its diagonals bisect one another. So that means that PR and QS, if they're bisecting each other, that means that this segment right here is exactly the same as that segment, and same here. So how about I go ahead and add one more letter where they meet. I'm going to call that M. Okay? So really what we're told is that QM is congruent to SM, and also PM is congruent to RM. And this theorem has kind of its complement as well, that if we're told that the diagonals of a quadrilateral bisect each other, then I can conclude that it is a parallelogram. And this is theorem 8.10. All right, so this time we're starting with the information that the diagonals of the shape bisect each other and they're congruent, and then I conclude, it's a parallelogram. So let's conclude with one example. For what value of x would MNPQ be a parallelogram? Okay, so if I want this to be a parallelogram, I have to show that the segments bisect each other. And I already can see that Q, if I was going to give this a letter, maybe just S, that QS and NS are already the same. So if I can just prove that these two segments are the same, then I can say, it is a parallelogram. So 2x has to equal 10 minus 3x to be a parallelogram. So if I add 3x to the other side, I get 5x is equal to 10. Divide both sides by 5, and I find that when x is equal to 2, it will be a parallelogram. If x is anything else, it's not going to be even segments here that were bisected. And that's all that we're going to talk about for parallelograms. So come to class ready with any questions that you have, and we're going to put all this into practice.